Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and let's try to solve it. So yeah, we will see the problem statement. Separate squares one. You are given a 2D integer array squares where squares of I is xi, yi, and li represents the coordinates of the bottom left point and the side length of the square parallel to the x-axis. And find the minimum y coordinate value of a horizontal line such that the total area of the squares above the line equals the total area of the squares below the line. Answers within 1 if minus 5 of the actual answer will be accepted. And it is to be noted that squares may overlap and overlapping area should be counted. Okay, you should not make any effort to actually not count the overlapping area. So that's what. So it makes the problem simpler actually. So what we can do is let's say if you are thinking that you can do this by iterating through the squares and just like sorting them in the order of y coordinate and just counting the area, then you might be wrong, because if you see in this problem, uh, you might be thinking that hey, I can place a y equals to one line easily over here, right? But if you see this second example, you see this is one square, uh, and this is another square in the top right. Okay, so you see, what is the sum of the area of them? So one is of side length 2, another is of side length 1. Okay, so the total area is 2 square plus 1 square, that is 5. Okay, and you need to divide the upper and the lower area into 2.5 and 2.5. Okay, so in order to do that, you might have to cut y to somewhere like this, where y is 1.16667. So yeah, as you can see, the below line has this area 2.5 and the above line also has 2.5, and since the areas above and below are equal, the output is this. 7 by 6 is the answer. Okay, y equals to 7 by 6. Okay, so at first, so see, if you proceed sequentially, you will easily get to the approach. So at first you might be thinking that hey, I can do some y iteration over the sorted squares in some linear manner. Okay, but after that you think that hey, linear manner would not be possible, because you see, I mean, how much more precisely can you traverse linearly? You cannot do it with so much precision. Okay, so another thing is that which immediately comes to your mind after this, that if linear search does not work, let's try out binary search, and yeah, it turns out that this will just work fine. So how exactly, what exactly is the idea? Why did I say you can do binary search? So uh, let's say you are starting from 2 points. So let's say this is your y coordinate, and this is also another y parallel to the x-axis, means y coordinate line. So let's say this is some r, and let's see the range till which the coordinates can extend. So they can extend from 0 to 1e9. Okay, so let's say r you initialize it to 1e9, and L you initialize it to 0. You see that what is the midpoint of this? So you calculate L plus R by 2. You try to do something like this. If you are trying to search a value, okay, mid equals to L plus R by 2, then you might find that hey, the area of the square, see, given a particular y coordinate, you can easily, by iterating, not even need to sort it. Okay, by iterating through the list of squares, you can easily find that what is the area of the squares above me and what is the area of the squares below me. Even if something like this is there, you can easily calculate this area and add it to the, let's say, upper area variable, and this you can take this area and add it to the lower area variable. Okay, so you can do it something like that, and let's say after all this calculation, you, let's say, figured out that 540.5 is the upper area and lower area is coming to be something 101.5. Okay, so what does it mean? What does it mean? That you, it simply means that hey, you should not move this line below. You should not move this line below, because if already the upper area is greater, if you move this line below, more upper area will increase more and lower area will decrease more. Okay, so you need to balance it, you need to make it equal. So this is not a solution, this is a solution. You need to move the this m upwards. So in order to move this m upwards, definitely what you can do, you can shift your search L. So you can do L equals to m. as you do L equals to M here, now L is modified and your new M value will be this, and your search space has reduced to this area. Okay, your search space has reduced to this area, and in this very similar manner, you can just keep deciding whether to go upwards or downwards. If you try to calculate very formally, you can just calculate two variables, upper area, okay, and lower area. You can have two variables, and if your upper area happens to be, let's say this is x and y, so if x is happens to be greater than y, what you can do, you can do L equals to M. L equals to M. If x is greater than y, you just do L equals to M. And else what you can do, else you can do R equals to M, and you can at the end return uh, L. Okay, return L, you can simply return L. And you see L or R anything, right? Because you see why this loop will go on till R minus L is while A is greater than or equals to 1e minus 5. So whatever range you want to put, how much you want to squeeze this L and R, that is C. If you squeeze this L and R to 1e minus 5, this M will automatically get squeezed even further. Okay. So yeah, so while R minus L is greater than or equals to 1e minus 5, you can simply do this thing, and x and y you can calculate. Let's say you do another function, you write another function which will tell you whether the upper area is greater or not. Okay. So yeah, I hope it is actually very clear, the solution. And if you think you have understood the solution, if you think you can code it out on your own right now, I will suggest you to drop out from the video and try it on your own. It will definitely help you to improve. Okay, and if you still did not able to solve, you can just keep following this video. Yeah. So, what are the things we need for binary search? We need to have a double L, which is initialized to 0, and R, which is initialized to 1e9. Okay, and while L is, you can say that while R minus L is greater than or equals to 1e minus 5. So yeah, that is the range which is given in the question. Answer is the 1e minus 5 should be accepted. So you need to squeeze it that much, and double will be then equals to double M will be L plus R by 2. I hope these things you know about binary search. Okay, and if you see, you can write a function of C. You are not getting this x and y value, so right now you need to calculate it via function. So x greater than y you cannot write here, so you can just write a function is upper area greater. You can write a function is the upper area greater. Take this M and take the squares and let me know. Okay, you tell this function, and if it happens to be greater, I will try to shift my lower pointer upwards so that my mid pointer also shifts upwards, and I am able to capture more in the lower area and less in the upper area because my upper area is greater. So yeah, I hope it is very simple, not at all difficult. And else what? Else R equals to M, and at the end you can simply return L. As simple as that. Okay. Now you simply need to implement this is upper area greater function. So this still is a boolean, returns a boolean. Okay, and you can write this function is upper area greater double M, and this whole thing vector int pass by reference of the square. Okay, and you just need to iterate through the squares and check. Okay, so you can have something like double. You want to calculate this upper area, you initialize it to 0 initially, and also you have this lower area initialized to 0, and at the end you can simply return whether this upper area which you calculated is greater than the lower area or not. Okay, so if it is greater, then return true, otherwise return false. Yeah, that's simple. And you can simply now iterate through this square. So int n is the length of iteration which you need to do. So for int I equals to 0, I less than n, I plus plus, int x I will be squares of I0, y I will be squares of I1, and What else? Li. The length is also given, right? Length of the square. So this is the bottom left point, bottom left x comma y coordinate of the square, and this is the length of the square that defines the whole square. Okay. I hope you can understand that. And now you need to check what are the things that I need to add to the upper area, what are the things that I need to add to the lower area. Okay. So how to check for that? You see, first of all, you are having this y, okay, and you are given coordinates, right? X comma y, xi, yi. Now the thing is that this is the bottom left coordinates, and the square will be looking something like this, and where this is the length li. Okay, all the lengths are li. So you see, this is, if this yi happens to be greater than or even equal to y, then everything will go to the upper area. The whole area will go to the upper area. Okay, so you can write a simple if statement. If uh, yi happens to be greater than or equals to my y. So what is y? This is the y, right? The m which I passed is actually y coordinate. Okay, which you are actually moving. Okay, so if this is true, what to do? You can add everything to your upper area. The whole what is the area which you need to add? You can typecast it to double and add li into li. I hope you do get it. Okay, area of a square. And else if you can have three cases, right? I hope you can easily visualize that. This is simple. That one case is that the whole area is upward. Another case is that the whole area is downward. And another case will be that some part is upward and some part is downward. So let's take the easy ones first. So if this is xi yi, okay, what is this length? This point is xi y, right? So what will be this point? This point will be uh, xi comma yi plus li, right? And this yi plus li, this yi plus li, this value has to be less than or equals to y. Okay. Then what you can do, you can add the whole area to the upper area, okay, lower area. So else if you see, you take this yi, take this li, and if you simply compare it with if it is less than or equals to y, then you can add everything to your lower area, right? So lower area to the whole of the lower area, you can simply add this. So yeah, you have it. And else what does it mean? Only one case remains, that is some part will be upward and some part will be downward. So how will you calculate that? See, again, this is xi comma yi, and this is and this point is xi comma yi plus li. Okay, so what is the area of this? This length into this breadth. This is now a rectangle. So this is li multiplied by this area is y minus yi. Okay. Okay. So one lower area, what you will add to the lower area? Li multiplied by y minus yi. Okay. This you can add it to the lower area. So lower area, what you can add is li multiplied by y minus yi. Okay. And upper area, to the upper area, what are you going to add? Definitely again you will have this li, and this is yi plus li. So this length will be yi plus li minus y. You subtract this y. So the length of the upper, this region of rectangle will be li multiplied by yi plus li minus y. Okay, I hope this is clear. No, not at all doubtful. So you are having yi plus li minus y. Okay, once you have all these, I hope this should work just simply fine, and there should be no difficulty, no confusion in this whole approach. Yeah, so you see, why did not I typecast it to double? Because see, this y is already double, so it will, at least one of the multiplying variables must be double. Okay, because you are storing this upper area and lower area into a double. So let's see. Let's try to run and check if it works. See, it works for these three test cases. Let's try to submit it and check if it works for all of them. So you see, it does work completely fine, and we have a decent runtime complexity also. I hope the problem was very clear to you, and this is a typical binary search problem. And yeah, that's all. That's all, I guess. That's all for this video. I will meet you in the next video. Till then, thanks a lot.